So in yesterday's class, we started discussing about the constructors and auxiliary constructor, how it will call, and how we can, in the primary constructor, if I declare var, what will happen? If I declare val, what will happen? If I didn't declare anything, what will happen? So these are the things we have discussed in the last class, right? And we have seen some examples as well according to that, right? So today, uh, see why we are more concentrating on this. Uh, Object-oriented programming language in Scala. uh, in the most of your code, which is in the Spark code, I mean to say, it will be object-oriented. In the Spark code, we'll be writing more classes and we'll be writing more methods, right? So it is not like only we'll write a transformations. It's not like only we will be applying it like map transformation, flat map, or count, or whatever it is. I mean actions. We're not going to do only the transformations. So in the real time, we'll be writing classes, we'll be having inheritance, we'll be having abstraction, we'll be having a traits, right? It's a combination of all of them. So that's the reason we're more concentrating on the more concentrating on this object-oriented programming. So that's where we started with the class, and that's where we started with trying to understand the object, what is a companion object, what is inheritance, and how they work, and how the constructors works, right? So so continuation to that, today we are going to see some more inheritance properties, or I can say class properties. We are going to talk about a few more things. Okay, so now, so can anyone tell me what is a primary constructor? What is a primary constructor in Scala? What is a primary constructor in Scala? So with Sudhir, Senka, Rangana, Vikas, and what is a yeah,
Primary constructor, which we call while creating the class itself, like we take as a parameter when we create a class.
mhm, okay, okay. So let me put a simple example here. Let me put into now. Normally, let's assume that if I want to write a class, or Pojo class ideally, okay. Let's say I want to write a uh, Pojo means plain old Java object. If I want to write a plain Pojo or Java bean in Java, what we will do, what we will do, we will write a class. We'll say person, and we'll be having our private members, something else. So then what we will do, we will write a setters, and we will write a getters, right? We will write setters and getters, right? So here each and everything we are specifying in the Java, right? But when it comes to the Scala, what Scala language says that instead of you write all this common boilerplate code, Scala says that I will give you, as being a language, I will give you these things. So there's a reason. Let's say if I want to write the same person in Scala, let's say I have a sal here, salary. I want salary should be final, and I want the salary should be only getter. I don't should have a set for the salary. Okay. So in this case, I can write a class where age int, where name string, val cell double. So now you tell me with a single line of statements, what are the things, I mean, with a single line of statement, what are the things are happening here? So what are the code it is giving you? What is the your Scala is giving you for the single line of code? If you see this, I want a setter getter for the age. Yes, the setters getters are available. I want setter and getter for the name. Yes, it is available. And only getter for the name. Yes, it is available. I want the constructor. Yes, it is available. Right? So with the single line of statement, your Scala is giving you, it's giving you the common boilerplate code, whatever the code you will be writing in that, right? It's giving everything in the single line of line, right? So here the primary constructor is, this is the primary constructor. This part we will call as a primary constructor. This call will call a primary constructor, and your class body, with class body, everything is a constructor body only. Everything is a constructor body. So whatever you write inside the class, that is a constructor body, right? Whatever you write a println statement, it can be println, it can be method, it can be variables, right? So what it is happening in the Scala class, it's taking everything into the Scala constructor body, but based on the way you use. Let's say I'm using instance variables, right? These are my instance variables. I have created instance for this person, like P1. So the P1 object contains this variables. P1 object contains this. It means everything is putting into the one constructor, and it is separating the pieces, like method is belong to instance, take it out. The variables are belong to instance, take it out, right? uh, that's where the primary constructor works in that way. Like the primary constructor is a constructor where everything comes under the primary constructor. At the class signature itself, we will write a primary constructor here, right? That's a primary constructor. So what is auxiliary constructor? We have seen already. We have seen so many examples. Auxiliary constructors are constructors which we will write explicitly by using a def and this keyword, right? We will write explicitly. What we will do, how we will write? We will write by using def and this, and there is some set of rules for the auxiliary constructor in this Scala. So your auxiliary constructor should call a primary constructor as a first line of the statement, and your primary constructor actually calls the base constructor. Internally, it is actually calls the base class constructor. Like, what is the top level class for your uh, classes in Scala? Any ref. There is something called any ref, right? So your constructor is called the base class constructor. This is how internally your Scala classes works. Now, what we are going to see as part of this class today, we are going to discuss, we have seen all of them, right? So we are going to see how to write a primary constructor. I mean, I can say private primary constructor. These are a little important, guys. So if you know more, if you understand the class, how the class works in this, it's a really easy for you to understand and the going forward. So I want to primary private. private primary constructor. What is the use of writing a private primary constructor? Can anyone tell me? Okay, what is the use of writing a private constructor in Java?
We will restrict it for that from direct calling actually, so that they will not able to call it and create the object.
Right?
Mostly for singleton we'll use this for a
Right? So when you create a private constructor for a class, you cannot really create an object for that class by outside, from outside, right? Yes or no? Look at here. I'm writing a class person person. So I'll show this. I'm going to show you a syntax how to write a private constructor here. You need to specify a private keyword after the class name and before your constructor. Before your constructor. Let's say I'm not going to write anything here. I am from private constructor. Oh, it's already defined before. Okay, I can take a different name. It's not a companion. The REPL is already I have already created a few things. Now it is telling me that the constructor person in a class person cannot be accessed in the object. Right? It's telling that you cannot go ahead and create an object for that. That is the purpose of the private constructor even in Java as well. Right? So if you want to write a private constructor in Scala, you will write a private keyword after the class name before your parameter list. Before your parameter list. That's how we will write a private constructor in this. Here. How we will write here? We will write such a way that class name, and we'll specify private here, and we'll specify list of your arguments. Okay, so if you make use of the private constructor, it's not allow you to create an object, and the main purpose of the creating a private constructors are to achieve the singleton. If I want to create my own singleton class, I will go with the private constructor, and I have to do I need to implement some more things, right? So let's say a simple example how we can create a singleton design pattern in a Scala. Any guesses how we will write a singleton design pattern? Singleton. So try to understand, guys, what is a singleton. Singleton is I can say singleton pattern. Whatever the class you write, entire life of that class it will give you only one object. It will not give you multiple objects. That's the purpose of it. Let's say here, if I have a person, I can create any number of objects like a person 1, person 2, person 3, and so on. But if it is a singleton class, I can create only one. I can create only one object for that. I can create only one object for that. right? That's where the difference comes with your singleton pattern and normal singleton objects or singleton classes with other normal classes, right? Let's try to write a simple class here. Let's try to write a simple class where we will be achieving like a singleton design pattern. Let me write the same class person. Okay, let me directly write into either ID. That's better. Writing here and killing some time. Singleton demo. And this, I should have a class. So by default, if you use object word in front of the any of the class, it is by default a singleton, right? If you use object word, object, actually here object is a singleton, right? But if you want to write your own singleton class, what we will do, we will go with the class private class private singleton person, right? I want to say it is singleton demo only because I'm going to use it. I'm going to use companion object here. I'm going to use a companion object. So let's say I don't have anything here. I can just have only two string method saying that I'm going to say only one thing here, two string method. I'll just go ahead and override two string method here, specifying that. So this is I'm from the singleton. I'm from the singleton. I just specify that. Returns. I'm from singleton. That's it. So here, what you are going to do, you are going to make use of. You're going to make use of. You're going to create an object for this, and you're going to now you have a private constructor there, right? It means that you cannot create any object. But I need a default object, right? My singleton should give you me an object. So since I have created a private constructor there, it will not allow me to create any object. It will not allow me to create any object. It will not allow me to create any object. So for that, what I need to do? First, I have to create an object. First, I have to create an object. First, I will create an object. Then I'll directly make use of that. Okay. Let's see this. LP equal to new singleton demo. Let's check singleton demo and and We need to assign this. We have created a singleton object. Once the singleton object is ready, we need to create. It should not give any. It should not allow me to create any object, but I have to allow through say a method, right? I should allow to create an object through a method. Get instance equal.
Bira, how you are able to calling the constructor directly? You have given it private, right?
That's what I'm trying to say. That's what I'm trying to look at. Let's see that. Otherwise, what I will do, I'll create here itself in the here itself. I'll try to call it. I'm just checking. Okay. So let me
Yeah.
finish this here. Okay. Now I'm creating a constructor. Here, I created instance. I'm assigning to get instance. So um, don't think it'll work, but let's see. So what error it throws? Let's see what error it throws. 1 second, guys. 1 second. Emma. Emma. కూర్చుంటావా బజ్జు బజ్జు 1 second, guys, please. Disturbance అవుతుంది నాన్న పడుకో. So I think it should not allow me to do this. Okay, now I'll do one thing. Okay, let's save it. Control F11. Why it's not throwing any error also? As soon as I call this, it has to call toString method, right? It is not allowing me to create a since it is not allowing me to create this. So for that, what I will do, I will have one more object here. One more object here, saying that which only creates instance as a companion, and here I'll say it is a test test where I'll try to access this val person equal to singleton demo dot get instance, and let's see what will happen. I hope it will work now. My class name is different.
It will not work, Bira. What I'm thinking.
Let's see that.
Yeah.
It's not showing any compiled error. Let's see. I think it worked. Let me put a printer statement. println, try to print person. Okay, right click, run as Java application. Yeah, it's working. It's working.
I am in a singleton demo.
Yep.
I don't know how come this new singleton is working. You have already given it as private, right? But you're able to call that constructor.
It is companion, right? It is a companion. Since
Okay.
your companion able to call any private members of your companion class. This is a companion object which has the same
Yes,
name
sir.
as your class name. That's one of the property of your
Hmm.
companion object, right? So not only the
Yes.
methods of your class you can access the private members also. So since your object is a singleton, object is a companion object here, which is able to create, which is able to call your companion class private constructor. If it is a other
Yes.
class, it will not call, right?
Correct.
That's the reason we have used companion here. Otherwise, it would have not work. Okay,
Okay.
let me go ahead and execute in the REPL. Oh, no, I think it's already defined. Anyway, it will be outside, right? Obviously, it will not execute. This is the REPL. What is the property? What is the condition of the companion? Both should be in the single file, right? Both should be in the
Yes.
same file. Your companion class and your companion object should be in the same file. As here, it is the same file. When I try to do then the REPL, it will not allow that way, right? It will treat as a two different statements, right? That's the reason. That's where it's working here, and it's not working there. Is it
Okay.
clear?
Okay. Do one thing. Call this get instance method one more time.
So whenever you call get instance, it will give the same object, right? It will not give the different object. Let me do one thing. Okay. Okay. You want me to call here one more time?
Yes. Get instance method.
Okay. Same object only, right? It's not a different object.
No, no. Not check the hash code value. Both the object.
Same object only, right?
I'm not getting actually, but this seems to be a little bit. See,
Mm,
in the first case, you have called singleton demo dot get instance. Okay.
mm.
So it's going to that object get instance method
It
p. It's
it
written.
return
So
the
p you have told new singleton.
it return the P.
Okay.
What is the P here? It's
Yeah.
an
So
object.
here one second. P is new singleton demo. Okay.
Mm,
So it's creating an object returning that object.
mm,
In the second case, you have written singleton demo
mm,
dot get instance.
mm,
So you are calling it one more time.
mm,
Okay.
mm. It gives the same P, right?
Oh, singleton demo is nothing but your same one, right? Same object only.
Mm.
So P equal new singleton demo.
Okay, so it gives the same
So
object.
basically, we are achieving through the singleton. See, singleton demo is ultimately a singleton object. Okay,
Mm.
and on top of that, we are creating is the same singleton object.
No, see, because if it is Java, I
Uh,
understand that in the same class itself you'll write everything and you'll be having a main method there and you'll start doing that.
correct,
Here, your class
correct,
cannot have a main method. If your class has a main method, you have to call explicitly. It will not work as,
correct.
it will not by default cannot text. So for that I need one
Mm-hmm.
object class, right? I need
Correct,
one
correct.
object. If I go with an object, class, if I try to see if it is a, let's say if it's a singleton 1, okay, look at
Yes.
here,
You will not able to call the private constructor.
correct? Since it is a companion object, I'm able to call it. It is
Yes.
treating as a part. It is treating as it is treating. It has a, I mean accessibility of calling your companion class. Even though it's a private, I'm able to do that.
Yes.
Okay. So anyway, we will discuss more about it in a later point of time. Anyway, this is in one of the interview they asked me to write a singleton class. This is how we have written. I think so, I
Okay.
mean more or less
Yeah.
errors we have written this way. So we will see that. Okay.
Yeah.
Yeah.
What is the use of singleton class? What you creating a singleton class?
I didn't get you. Could you please repeat? What is the use of?
No, what is the need of using the singleton class?
Okay. So the use of the singleton class is entire life of that application. Let's say I have written a big application. In that I have a one class. Okay. The class object has to be a single object. It should not create a multiple objects. The class whenever I create. See here I have created one object here and I have created one more object here. So it's the same or both are a single object only. It's not actually creating two objects. They're not actually creating a two objects. It's a single object only. Understand, right?
It is any performance issue or anything?
It is not.
Any other reason?
It is not a performance center. The requirement is that singleton is a one design pattern. It says that in a whole application there is a one class which has to give you only one object. Let's say Sunday. Okay, you have a Sunday,
Okay.
right? One of the day in the week. So if you call a Sunday in any of the object, let's say I can call a Sunday. I have a big application. Okay, in that I may create a hundreds of objects. Correct? On application, one
Okay.
Java
Okay.
application means so many classes will be there. So wherever I call
Okay.
the
Okay.
yeah, wherever I call Sunday, that should be same, right? Should not give different Sundays.
Yes. Yes. Yes.
That's the reason. Okay, you got it right.
Yes. Yes.
Now,
Thank
so
you.
yeah, so we have seen something like I okay, that's what we have achieved the singleton. Let's say even though your single line of statement, okay, as we discussed above, as we discussed above here, let me show this. Yes, you were declaring a var declaring a val here, even though it is giving you a setter and getter methods, those are not actually Java bean setters and getters. Correct? Yes or no? Those are not actually complaining. I mean, it's not actually your setters and getters. Like you cannot go ahead and say uh, set name or set age. You cannot really do that. Even though your compiler is giving you an access, it's just giving you an access. You are not going to really use of them. Suppose the same Scala code I want to make use in Java. Obvious, right? It's possible, right? Can I make use of my Scala code in Java? Can I make use of my Scala code in Java? Can I make use of my Java code in Scala? It's fully supported or not?
Yes, you can.
It is fully
Yeah. Yeah.
supported. Since your Scala also going to work on top of JVM, your Java code also converts into JVM, your Scala code also converts into JVM. I mean, converts in the sense it converts into bytecode, I'm trying to say. So both works on the JVM. It allows you happily. It will not give you any error. It allows you happily. But I have written some class in Scala, but I want to do something like setters and getters for that, right? I want to do a setters and getters, like I want the full-fledged Java bean for that class. So what I will do? So if Scala by default it gives the setters and getters based on the val where we have defining in the constructor, and if you didn't define anything, it will not come any it will not give you any setters and getters, right? That's what we have seen in the last class, right? We can prevent the setters we can prevent the setters getters by using private as well. So that's what we have seen yesterday, right? So today I want a full-fledged Java bean for my Scala class. What we can do, there is some annotation. there's an annotation. That annotation is at the rate, sorry guys, 1 second, at the rate, at the rate bean property. We need to specify bean property. We are specifying that it is a bean, it's a bean property. It is a bean property. If you use before, let's say I have a constructor here, I'm going to write an example. Class person, class person. What I'm trying to do here, I'm very bad in that. At the rate bean property, you can specify your val or you can specify your whatever the var age int at the rate bean property val double. Like that we will use a bean property annotation here. When you specify that, when you specify that your Scala internally, right, it actually uses the reflection. It actually uses the reflection API, and it will create the setters and getters. It creates external setters and getters for you. Not only constructor guys, you can also write outside. Don't think that we'll write always in the constructor. So it can be written outside the constructor also. Okay, it's allowed to do that. No need to write in the always in the constructor. So as a property.
Bira, actually, can you tell what it is doing actually? Creating setter and getter.
Setters and getters, and where you can make use of those setters and getters in Java. You, let's say you have a Java
Okay,
class.
okay,
Yes.
okay.
So this class I have written person, right? So now this person
Yes.
I required into Java, right? So in the Java, what I can do, person p equal to new person, and p dot set name, p dot get name, or p dot set age, p dot get age. I can do those methods. I can directly call those methods.
Okay.
Do you guys understand what I'm trying to explain?
Yeah, what is the bean, Vera?
Okay. So bean is like a Pojo. If you guys remember in our Java classes, there is something called Pojo. Pojo means plain old Java object. So when I say Pojo, it does not contain anything else. It contains the private methods or private variables, and it contains the setters and getters and getters. I think we have discussed more about this in a polymorphism, not polymorphism, encapsulation. If you guys remember, in Java we have discussed when we are talking about the encapsulation. So let's say I have a person class. In this person class, I'll be having a private int age, private string name. I'll be having all the private properties. These private properties I can access through public methods. Like I'll be having a setter here. Public void void, it's not D, it's just void, void set age. I hope you might have seen this. And this dot age equal to age. Do you remember, Ranganath, we have written such kind of things in Java?
Yeah, yeah, I remember.
So what it is, I have a private properties. These private properties are getting exposed outside the world through public methods. Suppose if you want to set any value to this age, you cannot directly access this object outside. Since they are private, they are not accessible, correct? This age, name, and salary, they are not accessible outside this class. If you want to access them, you have to access through the methods only, public methods only. That type of, if you see that kind of object, we'll call as a Pojo. You can say it's a bean, Java bean. You can say it's a Java bean. Okay.
Okay.
So how to write and all? As I told you, you have to write your Scala classes like this, and these Scala classes should have the same package name, and your Java, wherever you're going to write your Java class. Let's say I'm going to write my Java class. Let's say this is my person bean. Now I'm going to write my Java class. Okay, let's say test Java class. This is there in the package called uh, com dot scala dot person. So my Java class also should have the same package, com dot scala dot person. Then this is my Java class. Okay, I'm not writing everything here. What I need to do, I'll be having my main method. In the main method, what I will do, I'll just create object for this. How to create objects in Java? Let's say person p equal to new person. If you have any parameters to pass, you can pass, else no need. Now p dot set age. I can do this. P dot set name. I can do this. But this is not why I'm able to do this. Since my Scala class is full-fledged eligible Java bean. Eligible Java bean. The previous one, if you guys remember, we have done the similar kind of thing here only. We have seen a few examples, if you guys remember. It's not there. So it is giving you a getter. It's not actually a set get. It's not actually a get. It is a method. It is giving an access to you. That's where the difference comes, guys. So I'm trying to show you the difference here. If you are using a Java bean property, it means it's a full-fledged Java bean. But this is not actually a bean. What we have seen in the last class and the previous class, those are not actually a bean. Those are not actually giving you setters and getters access. Those are giving you how to access of your properties, how to access your properties in a class. Do you guys able to make out the difference?
So for val property, it's not giving setter, right?
It's not property, it will not give a setter.
Okay.
It will not give the setter. Val is its own allow you to do a getter.
Yeah.
Is that clear? Okay. So to make use of this bean property, the bean property is not available by default. You have to import a package. So I think we didn't see a single statement of writing an import statement, right? In the Scala, the import statements are as similar as Java. So nothing different, nothing difference here. But in import, right, you have the Scala imports are far better than Java. I mean, better in the sense it is improved. I'm not trying to say Java is worse than Scala. No, I'm not telling that. You have more features of writing in the Scala. Let's say I want to write import here. What I will do, import, and I will write my same as your, it will really not change your syntax the way you write in the Scala and Java. So here Scala dot your reflection. So as I told you, reflect. You have something called reflect and bin property. Bin property. So what I was trying to say, it was improved. I mean, different ways we can write in import statements, right? In Scala, you can write import statements anywhere in the code, anywhere in the code. Wherever you want, you can go ahead and write anywhere into the code. That's one feature. The second one is in import, right? While I'm importing this bean property, I want to rename to this bean property. Let's say I want to rename this bean property to, let's say, BP. I can rename like this. I can rename like this. An import statement, whatever I have imported here, I want to rename it. I want to rename it. Let's say import. Let's assume that I'm importing a map. Okay. let's say Java dot let's say Scala dot immutable dot map. So here it is immutable map, right? And the same way you have a mutable map. Okay, now I want to make sure the difference between these two. So in my code, if I'm using map, which map I'm using? Am I using immutable or a mutable map? Am I using a mutable map or immutable map? How will I know that? Suppose I want to make a difference here. What I can do? I can rename this. I can rename this such a way that I map. I can rename this mmap, mutable map. So wherever I use mmap, wherever I use imap, I can clearly see the difference there. I can clearly see the difference. That's where the little difference between the import statements. Is it clear to everyone about the Java beans, about the singleton, and about the imports? Imports is not really that much great. So we will be it will get on the fly. You will learn how will you do in the I can say in the work. You can easily learn that in the on the way of your writing a work. And also your import also, you can also restrict the import. One more feature of import is you can say from the import, let's say I want to get only two classes, I don't want all the classes. You can just specify import, I'm just giving an example, Scala class, Scala dot, let's say reflect only. You can specify that. You can just use a curly braces. You can say your bean property and something else, some other bean you want to use. Only these two only you want to use. So you can make use of like this. You can make use of like this. Okay, you can make use of like that. Is it clear, guys? Is it
Yes,
clear?
sir.
So
Yeah.
this is how we rename. This is how we rename. This is how we import normally. Wherever you want import, you can import. And the second one is you can rename. And the third one is you can what are the classes you want to import, you can import directly. Only those classes. Only those classes. Okay. That's it about this. Let's let's move on. Let's move on to abstraction. What is abstraction? What is an abstraction? What is an abstraction? Why I need abstraction? Why I need abstract classes? It's one of the feature of whoops, right? So why I need abstraction? Why?
If you don't want to show anything to the outer world, you want to hide something, then the concept is called abstraction, because you don't want the user to know about the internals. You
Mhm.
just want to give him some features, not the internal thing.
Okay. So any example?
Any means if I am a user, okay,
Mm,
who is going to purchase the mobile,
mm.
I will not give him the information about the how the hardwares are working. I will
Correct.
just tell him the features.
Correct.
This kind of thing.
Yeah. So the very good example because so abstraction is hiding the implementation details and provide the only functionality. Hiding the implementation details and provide the only functionality. So if you guys remember in Java we discussed about, we have taken some car example, we have taken some mobile example, we have taken some bike example. You really no need to know how internally the messaging work. You should know how to send a message. You really no need to know how internally the WhatsApp is working, how it is sending the message. So from one system to another, I mean from one mobile to another mobile, how it is sending a message. You just need to know how to make use of the WhatsApp message. And you really no need to know how your fuel is converting into power while you are driving your car, while you are riding your bike, right? So you just need to know how to make use of it. And you really no need to know how, when you apply a brake, how it is getting applied internally. So it means we are hiding the implementation details and we are providing only the functionality to the end user. That's called abstraction. So since even Scala is object-oriented programming language, yours Scala also supports abstraction. abstraction, right? So if you remember, we have abstract methods, and we have abstract classes, right? What is abstract methods? A method which will not contain any body. A method will not be contain body. It will not contain any body. It will contain only the declaration, right? And abstract class is a class which will contain the concrete methods and which will contain the concrete methods and abstract methods, right? Abstract class is a class where it will contain abstract methods and concrete methods, and we to make sure that we will use the we will use the abstract is the keyword for that, correct? We will use the abstract is the keyword for that. We will use the abstract is the keyword. If I use a keyword abstract in front of the class, if I use the abstract keyword in front of the class is abstract class. I cannot go ahead and create a instance for this. I cannot go ahead and create instance for this. It will not really allow. It will not allow me to create a instance for this. That means I cannot create object for this. If I declare a abstract in front of the method, I cannot be having a body for this. I cannot have a body for this, right? I cannot have a body for this. So abstract methods are meant to provide the implementation in the following class or in the child class, right? If my child class, see, if you have abstract class, guys, if you guys remember, if anyone wants to take, is guys can go back and have a look about the abstract classes in Java. You can have a constructor here. We already discussed about it. Okay, we can have a constructor. We can have a blocks. We can have a private concrete methods. We can have a private concrete methods. Let's say we can have a private concrete methods. Okay, so what is the use of having a constructor here? Since it is not allowing to create object, what is the use of the calling? What is the use of the constructor in this? So the as you told, the it is abstract class. It has to be implemented by someone. I mean, it has to be extended by someone. The child class should extend it. If I have a private method here, it cannot be the private methods cannot be available outside the class. So then what is the use of this? So these are all we have discussed in the while we are talking about abstraction. While we are talking about abstraction, and these are also an interview questions. They may ask that, so can I have a private constructor, or sorry, can I have a constructor in the abstract classes? Can I have a private methods in the abstract classes? Can I have a main method in the abstract class? Can I have a main method in the abstract class? So these are the questions we may come across in Java interview, right? So then if it is, what is the use of them? These are all and interview questions about the abstract. I recommend you to go through the abstract classes before attending tomorrow's abstraction trade class. So I recommend you to go through this. When it comes to the Scala, you have abstract methods as well as you have abstract fields and you have abstract classes. Here in Scala, you can also have abstract fields, field in the sense your variables, and you can have abstract methods. You can have abstract classes. The functionality is everything is same as your Java. Nothing changes here. The abstraction itself is hiding implementation details. The Scala also is the same. The way we write is little different. The way we write little different. Okay, and also as we discussed in the previous class, we can override. Obviously, if you are going with the abstract methods, you have to override that in this base subclass. This method has to be overridden in the subclass. Not only these methods, a variable also we can override. The variables also we can override in the base subclass. And how we will override we will see in the next class by using override keyword or override annotation, right? if I don't want to override in the subclass, let's say I have a car here is an abstract class, right? I have a class called BMW extends car. I should provide implementation for what are the abstract methods are there in this class. If I don't want to provide implementation for those abstract methods, those abstract methods which are there in this class, I myself also has to be, this BMW also has to be abstract, else it will throw an exception, right? The same features in Scala as well. Even if we have abstract class, abstract Scala class, if a child class is not going to implement the abstract methods, the child class should declare as abstract. Okay, the same as your Java here. Okay, that we will see in the next class, and we'll also discuss about the traits. So as I told you, traits are really important. Without having a trait in your interview, they'll not complete your Scala interview. If you guys remember, abstraction and interface both are most important interview questions in Java as part of the core Java. I didn't see any interview asking we're not asking the what is abstract. They'll surely ask, until unless they are identify that you are really good in the base constructs. They may not ask this question. Otherwise they will go ahead and ask what is abstract and what is the interface, how they'll work, what is the difference between, and what is the Java 8. In Java 8 there are something called default methods. So if you guys remember, in interface we can have only abstract methods. We can have only abstract methods before Java 8. I'm talking about before Java 8. In Java 8 there is something called default methods. Default methods mean in interface itself you can have a method which has a body, which has a body. The reason behind it, from last 15 to 20 years we have written so many interfaces, and I want to introduce a new function for that interface, a new method to that interface. See, if I write any abstract, new abstract, let me put in this example. I have interface 1 which has a method 1, method 2. This interface has been implemented by 20 classes. Let's assume that 20 classes are implemented this interface. So they already implemented these two methods. The 20 classes implemented M1 and M2. Now I want a new method here, that's M3. If I introduce a new method in this, that's my requirement. The requirement is came like in this interface, I want to get the new method M3. So now I have to go ahead and change all these 20 classes. Or I need to create one abstract class. In the abstract class I need to provide a body for this. I need to bring an abstract class in between here. Implement that abstract class by this interface and provide a body for this in this abstract. Then you can extend this abstract whichever the class you want. Guys, that's the design I'm talking about. Okay, so if you are not getting, is really not to worry, just try to understand. If I have an interface already, this may be a scenario based interview question you may come across. I have an interface which has a method 1 and method 2, and that has been implemented in the 20 classes. 20 classes has been implemented those things. Now I want to bring a new method into this class. I want to bring new method into this interface. Sorry, not a class. I want to bring a new method into this interface. Now if I write this new method in this interface, I have to go and touch all these 20. I have to go ahead and modify all these 20 classes. Or an alternative is create an abstract. Let's say only M3 class implements your I1 and provide a body whichever the interface you want to implement, right? Provide the body for that, and whichever the classes you want to implement this, whichever the class 21 class you want to, let's say 21th class implements I1. I mean, actually you should write a first extends M3 class, implements I1, then only it will work. Otherwise you have to touch all 20 classes. To avoid this criticality, Java 8 come up with something called default functions in the interface. So directly you can have a default or body which has the body concrete method in the interface, and you can implement only that method in the whichever the class you are going to write it. Okay, that's the use of the default functions in Java 8. Okay, anyway, we are not going to really worry about that. We'll be seeing that in the next, in the traits how it will work. There is something called traits, so which is similar to Java 8 functionality, but more than that, it has a more features than that. Okay, we'll be discussing that in the next class. Any doubts? Any doubts? Yeah. So that's it for today, guys. We will see on the rest of the things in the next class. Yeah. Thank you for your time. Have a wonderful day.